All right, we're starting Unit 3, which is called Polynomial Functions. Our first topic is looking at the characteristics of polynomial functions, and that's found on pages 106 to 117 in your text. Our curriculum outcomes, we're looking at 30.10, which says we need to demonstrate understanding of polynomials and polynomial functions of degree greater than 2, limited to polynomials of degree less than or equal to 5, and limited to integral coefficients. And we'll talk about that in this lesson. Our lesson objectives, you need to be able to identify a polynomial function and state the degree of a polynomial function. You need to be able to identify the end behavior of a polynomial function based on its degree and its leading coefficient. And you need to be able to identify the possible number of x-intercepts of a polynomial function based on its degree. So a polynomial function is one that can be written like ax to the n plus bx to the n minus 1 plus ... plus c, where n is a positive whole number and a, b, and c are any number. So notice that the exponent on your x is going down each time. So we call a, this number in front, we call that the leading coefficient because it's in the lead. N is called the degree, and the degree is basically your highest exponent. And you need to know that polynomials are always written in descending order, which means your highest exponent comes first, then your next highest exponent, etc., 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 all the way down to the constant. So some examples of polynomial functions. You've seen some already. We've talked about parabolas. So a parabola is a polynomial function, 2x squared plus 4x plus 1. In this case, we have a leading coefficient of 2, and we also have a degree of 2. Another example would be anything, we could have high exponents that you haven't quite encountered yet, x to the 7th plus 4x to the 4th minus 3x plus 2. That's a polynomial. In this case, the leading coefficient would be 1, and our degree is 7. We also have non-examples, so things that are not polynomials are absolute value functions, not a polynomial, because there's no degree. Things like root functions, square root of 2x minus 1. That would be written with an exponent as 2x minus 1 to the power of a half. Now, we need our exponents to be whole numbers, and that is not the case here. So these radical functions, as we learned last unit, are not polynomial functions. So the degree and the leading coefficient both have an effect on what quadrant the graph starts and finishes in, and this is called the end behavior. And this is what we're really looking at in this lesson today. Okay, so we've opened up GeoGebra, and I've got a few functions we're going to look at. We're going to look at our plain old parabola, which is f of x equals x squared. And we're going to look at g of x equals x to the 4th minus 5x squared plus 4. Now, what we're really concentrating on right now is what quadrant it starts in and what quadrant it finishes in. So we have our quadrants labeled 1, 2, 3, and 4. And if I look at x squared, I can see that it starts in quadrant number 2 and ends in quadrant number 1. If I look at g of x, I see that it too starts in quadrant number 2 and ends in quadrant number 1. Now we read these like we read a book, which is left to right. So that's why we keep on saying, I keep on saying, that it starts in 2 and ends in 1. It starts on the left-hand side, ends in the right-hand side. Another important thing to notice is that in a function that has a degree of 2, there could be a possible 2 x-intercepts. So if we were to pull down this blue function, we could have 2 x-intercepts. A function that starts with a degree of 4, it has possible 4 x-intercepts, as we can see the red function there. So we've got a even degree, a degree of 2 and degree of 4, and it looks like they both start and finish in the same quadrants. Now, if I just take the negative of those two functions, so negative x squared, that's just an upside down parabola, it starts in 3 and ends in 4. If I take a negative of our g of x function, so negative of x to the 4th minus 5x squared plus 4, I notice that it too starts in 3 and ends in 4. So our generalizations that we can make is that if it's even, and if the degree is even, and it is a positive leading coefficient, like positive x squared and positive x to the 4th, it's always going to start in 2 and end in 1. And if it's a negative leading coefficient, but still an even degree, it's going to start in 3 and end in 4. Okay, so we just looked at what happened when we had functions with even degrees. Let's take a look at what happens when we have functions with odd degrees. So I'm looking at our basic function, f of x equals x. We know that to be a line that travels right through the origin. And we're going to look at another function, x cubed minus 4x squared plus x plus 3. So here we have another odd degree. So here the degree would be 1, and over here the degree is 3. And we can see that on the left-hand side, this function starts in quadrant 3, and then it ends in quadrant 1. Both the blue and the red function start in quadrant 3 and end in quadrant 1. Well, I'm going to do the same thing. I'm going to take a look at odd degree, but this time I'm going to look at when it has a negative leading coefficient. So h of x equals negative x, and p of x equals negative x cubed. And in both cases, once again, they start in the same quadrant, which happens to be quadrant number 2. And they both end in the same quadrant, which is quadrant number 4. So our generalization here is that if we have an odd degree and it's a positive leading coefficient, it's going to start in quadrant 3 and end in quadrant 1. If we have a negative leading coefficient but still an odd degree, like negative x and negative x cubed, we know that it starts in 2 but ends in 4. So those are just some generalizations that we can make based purely on the degree and the leading coefficient. Now you can open up a GeoGebra or another graphing program if you like. You can try functions that look like x to the 5th, x to the 7th. You're going to find the same sort of things. Now, we talked a little bit about x-intercepts just a second ago. In a function like f of x equals x, we know that there should only be one x-intercept because the degree is 1. And in x cubed, we should be able to have up to 3 x-intercepts. And there's our 3 x-intercepts. So the degree not only tells you where it starts and finishes, but it also tells you how many x-intercepts there might be. Not always, but there could be. So, in summary, we know that the degree is really important and the leading coefficient is really important because they will both tell you which quadrant the polynomial function will start and end in. And we also know that the degree will tell you the number of possible x-intercepts. So it tells you a couple of things, that degree. Now, I've summarized all this information in a little table. And this little table is kind of easy, not necessarily to memorize, but if you use a little bit of logic, you should be able to understand where functions start and end. If we're talking about even degrees, we're looking at things like parabolas. We're looking at things like x to the 4th, x to the 6th. And if it's positive, we know it's going to start in 2 and end in 1, because that's what a normal parabola does. Starts in 2 and ends in 1. So I've put in this column here, it says acts like. These sort of functions, leading coefficient that's positive, a degree that's even, so it could be 2, 4, 6, 8, 10, 12, whatever, is always going to start in quadrant 2, and it's always going to end in quadrant 1, just like a regular parabola. If that leading coefficient is negative, but the degree is still even, it's going to be like a negative parabola, where it starts in quadrant 3 and ends in quadrant 4. If we're looking at a odd degree, so 1, 3, 5, 7, etc., and it's a positive polynomial function, it's going to start in quadrant 3 and end in quadrant 1. It's going to act just like a line would act, starting in quadrant 3, ending in quadrant 1. And if that leading coefficient happens to be negative and the degree is odd, it's going to start in quadrant 2 and end in 4, just like a negative sloped line would do. Start in quadrant 2, end in quadrant 4. So it's not necessarily something you need to memorize, but it is something that you need to understand, and understanding is always better than memorizing, I think. And that is it. This table pretty much wraps up the whole lesson. If you can understand that, you're good to go. Your assignment is on pages 114 to 117. Good luck and see you tomorrow.